Hello everyone, welcome to the Linux Kernel Module presentation from tutorialsstudy.com. In the previous slides, we have discussed about device drivers, what is device driver, what is the role of device driver, what is the Linux kernel architecture, how to build and compile Linux kernel. In this slide or in this presentation, agenda will be what are loadable kernel modules, why loadable kernel modules were introduced, what are the benefits of kernel modules, what are the uses of loadable kernel modules, how loadable kernel modules are different with user space modules. So previously what was happening, like whenever you write some code, whenever you write some piece of code and you want to add that code into your kernel, what you would have to do is you have to compile your code with the kernel. Now the question is how you can compile the code with your kernel. You can place your code in any of the kernel directory. You have to change little bit in the make file of that directory. So once you compile the whole kernel, your code will also compile together with the Linux kernel code, and the outcome of building will be Linux kernel image that will come with your code included. So the thing is, now whatever the image we got, that Linux kernel image contain both things, Linux kernel also and your code image also. But now the thing is, suppose if you want to do some little change in your code, what you have to do is you have to again build the whole kernel again, and after that you will again get the Linux kernel image. You have to again boot your device. So don't you think it's a very complex task of changing little bit code and again building the whole Linux kernel and then again rebooting the system? So this task consumes lot of time, and this is not an efficient approach. So to avoid this limitation and with other limitation, Linux introduced the concept of loadable kernel modules. So let's first understand what is the kernel modules. Kernel module is the piece of code which can be loaded and unloaded into the kernel upon demand. Means whenever you require a module, you can load into the kernel, and whenever you don't require the module, you can unload it by using some Linux commands. So means you can load and unload kernel module dynamically. So suppose for a particular time, suppose take example of your system is booting or your hardware is booting. So one thing is you have compiled USB driver with your kernel. So but the thing is, after booting the kernel, you didn't attach any of the USB device with your system. So your kernel module, your USB module was unnecessarily loaded into the kernel module. Instead of that, we could have removed that. So to avoid that, we came across the feature of loading and unloading modules on the demand. Suppose you want to use some drivers, suppose you want to use USB device, so for that you need USB driver. So what you can do is you can load the driver for that USB into the system. After loading of the driver, your USB will start, your USB port will up, and you can start using USB. This exactly happens in our real case scenario. If you have PC, so whenever you insert some pen drive into the system, you see like driver installations notification comes on the screen. So what does that means is, that means like USB modules or USB driver modules start installing into your machines. So after the installation, your USB device is ready to use. So this how it happens. So this is the Linux kernel code, and this is your code, means your module. So what you have to do is you have to compile your Linux code separately, and it will give you Linux kernel image that doesn't include your code image. And when you compile your code independently as a module, you will get your code image. So after kernel module is compiled, you can flash it onto your target device and you can boot your device. Once device is putting fine, you can load your driver or you can load your module whenever it's required. So you can load and unload your module by using of some Linux commands. For example, for loading we use insmod and modpro, and whenever work required is done by module and you don't require driver now with your module, so what you can do is you can unload by using rmmod command provided by Linux kernel. So now let's understand what is the benefit of kernel module. One benefit we have already discussed, like we no need to build Linux kernel again and again whenever you do some change in your code. You can change your code separately and you can load and unload your code whenever you require. Okay, so what is the benefit of that? Benefit of that is, if you compile your code with the kernel itself, then your image size will be very large. But nowadays we are getting small hardware which has very less memory. So in that case, like, this will be wastage of our precious memory. So to avoid this, the good approach is to load the part or to load the kernel module whenever it required, or whenever it's not required, just unload it, so that we can save memory also. And the other thing is, you can easily debug any issue by using modules. How so? The thing is, suppose you have done some changes in your code and you are compiling it with the kernel with the older approach. So what will happen when you try to boot the kernel with the code, with your code? So that might be scenario like your system is not booting up. Now you are not sure like whether there is mistake in the base kernel code or in your part. So that will be the confusion. So it will be very typical for you to understand the issue or to debug it further. But in case of kernel module, what will happen? First you will compile the Linux kernel code, you will boot the kernel code, you will boot the base kernel. If your system is fine, then you will try to insert your code or module. If after loading of your module there is some issue, so you can say like this issue belongs to your code. So you can debug your code separately without disturbing the Linux kernel. And after that, performance wise, if you will see, if you will compile your code with the kernel or if you will compile your code as a module, performance will be same only. And the other benefit is you can frequently change your code, because now you don't need to build Linux kernel again and again, and building of module will take very less time as compared to building the whole kernel module. So it is very efficiently approached. So because of these many features, because of these many feature provided by Linux kernel modules, the uses of Linux kernel modules is also vast. So I have listed 3 things in which we use Linux kernel modules majorly. One thing is device driver. As we have discussed in the previous presentations, device driver is the piece of code which actually interact with the hardware or which manages an interface between user space, applications and hardware. So this driver code is compiled as a module. So whenever we require device driver for some particular hardware, we can load it, and whenever we don't require, we can unload it. Other thing is file system drivers. Our system, suppose take example of your PC. At the same time your PC might be connected to multiple devices. Take example of hard disk, USB and some other device, and each of the devices might have different file systems. So these file systems provide different way of accessing the data. So who provide this page of accessing the data? These ways are provided by file system drivers. So generally all these file systems drivers are loaded and unloaded like a driver modules or Linux kernel modules. And the other thing is system calls. As you have discussed, system call is the interface which provide syscodes or system calls APIs to the user space. By using of syscalls, user space application can get the limited access to the hardware. So our syscalls, whenever you want to write any new syscall, so people generally prefer to write syscall as a Linux kernel module, which you can load it and unload it according to your requirement. So now it's time to understand. You might be confused, like we generally write a user space module also, like you are writing some C program. So that is also a part of your module. But there is a lot of difference between kernel module or user module. Whatever the C program you write, that is a user space module. Whatever the device driver code you write, that is a kernel module. And now let's understand the difference between each. User modules runs in user space. Means user modules has access to only the user space memory. But kernel modules runs in kernel space, so they have high privilege. Means they can access all the memory of the system. And kernel module can handle the interrupt. Your device might be generating some interrupt, so you can handle in your driver. But user space module cannot handle any interrupt. Benefit of user module is that whenever there is some serious issue, because of that issue in the user space, because of that issue, our kernel cannot crash or our system cannot crash. But as kernel module runs in kernel space or privilege space, if any serious bug occurs or if any issue occurs in the kernel modules, they can cause whole system crash. And even if you will see the code of user space module, they are generally written, the first function to be called in that module will be main function, but here in kernel modules the architecture of code will be totally different. That is also the difference between both. So that was all from my side from Linux kernel modules. This presentation explained only the theoretical part of Linux kernel module. In the next presentation we will try to write one hello world driver and we will compile it as a Linux kernel module. We will load it and unload it and we will see what happens in the kernel logs when we load and unload the module. If you have any query, you can post your question anytime at www.tutorialstudy.com. We have created one form for that. You can anytime post your questions or query. Please feel free to post it. If you like our videos, you can always subscribe to our channel for more videos. You can connect with us on Facebook, www.facebook.com/tutorialsdaddy. You can visit our website and subscribe for more updates. Our website is www.tutorialsdaddy.com. Thank you so much for watching our video.